Okay, recording. 3. Hit send on it. 3, 2, 1, start. Hello. I'm making this video to show you a project I've been working on. It's an 8 or 16 channel controller that can drive LEDs or other devices, and it has both a little bit of hardware and a little language that you can use to program the controller to do what you want. And all the programming is done wirelessly over Wi-Fi. So to start with, we have a little ESP32 processor. So this little processor here is 32 bits. It has 16 channels of PWM output that we're going to be using to drive things, and it also has onboard Wi-Fi. So we have one of those. Next, this is the little board that I built. So it's really simple. The ESP just fits there on the top, typically on headers, and then at the bottom across here we have a set of MOSFETs. So tiny little MOSFETs. They're spec'd to drive a little over 3 amps each. So reasonably powerful for their size. And when you put them together, the board has some headers here on the top, and the ESP just plugs in. And here at the bottom I have, some headers coming out, and then some LEDs that I just use for practice when I'm doing this. And this gives us 8 channels out. So the board had 8 MOSFETs, so that gives us 8 channels. If you want 16, you can take a second board and kind of put it in extension board mode, and then a little header on the bottom of the main board, and then I can just clamp those together, and that now gives me 8 channels here for the LEDs and another 8 channels here that I could hook up. So 16 channels, full PWM done in hardware on the ESP. So very nice capability. So let me pull that off since we're not using that. Now for the purpose of what I'm showing you, you'll notice that there's a USB cable connected to this. The USB cable is really only there for power and for power, and also for sending debugging commands back from the ESP to a console. We're not sending any commands over. All the commands are going on wireless. So now let's flip over to my desktop, and we'll see I have 2 windows. Over here on the right, I'll clear this out. This is just a terminal monitor, so it's showing the data that's coming back, mostly debugging data from the ESP. And then over here on the other left, I have a web browser, and it's running a web page. And the web page is coming over wireless from the ESP. So I just hit the IP address for the ESP, and it creates and formats this web page and sends it back. So you can think of this as a really, really simple IDE for doing development on this board. So let's get started. I have another window you can't see that has some commands typed up, and I'm just going to be using cut and paste just to kind of speed things up. So to start with, basically the whole point of this language is to be doing animation. So kind of the root commands, this is a command called D, which means direct, basically, and it has 3 parameters. This first parameter is how long we want an animation to take, and this is expressed in 10 millisecond units. So 100 means a second. So I want this thing to take a second. The next parameter is the channel. So channel 1, the channels are numbered 0 through N. So for this thing, I'll be showing you 0 through 7 because I have 7 LEDs. I have 8 LEDs. It would be through 15 if I had the expansion hooked up. And then finally the target brightness that I want at the end of this animation. So basically it's going to start at whatever brightness channel 1 is, and over a second it's going to drive that brightness to 1, which is fully bright. The A command here actually means do the animation. So you can think of the D command as defining an animation, and the A command means do an animation. And then we're going to do an animation in the opposite direction. So from whatever it is, which will be 1, back down to 0, and then do animate again. So I can do send, and if we look at the device, what is it doing? It's animating the first LED from off all the way to on. And when it gets to the end of the command string, or the end of the program here, it's just going to loop around, which is why it keeps running. Now, one of the other features of this little IDE environment, there's this error window here over on the right. So if I make a mistake here, if I get a wrong command, what happens is I send it across, and the ESP now has an invalid program. So it's going to stop executing, because if you execute invalid programs, often you can lock the system or cause it to reboot, and we don't want that sort of behavior. And what we see is it sent back an actual description. So invalid D command expected an I or a parenthesis. So it can give you a lot of debugging there. And I'll send it again. It'll go back, and now we're executing again. Now if we look over at our monitor here, we'll see that it's giving us some more info. You can see here there was a new program, so this is what it shows when a new program comes across. It saved it off to non-volatile memory, but it found some errors when it started to execute, so it stopped executing. So it'll flip between executing mode. If it finds errors, it'll flip back into non-executing mode. And then when I fixed it, sent the program across again, and then it did the save off to non-volatile, and we're back running again. So that's our first little program. So let me go grab the second one. Now obviously driving one channel at a time isn't really very exciting, so we're going to drive multiple channels. This does the same thing as the first one, except it does both channel 1 and channel 2, and channel 2 is done in the opposite manner. So if we go and execute this, we'll see channel 1 goes bright, and they kind of oscillate between each other. Kind of hard to see that on the LEDs. I think you can kind of see it. Now, take my word for it. One LED is going bright while the other goes dim. The first one goes dim while the other one goes bright. So this sort of thing is pretty common. Wanting to do multiple things. So what we do is the D command actually allows you to specify more than one operation. So what I can do is I can do that. So I have a single D command to do the first thing, and a single D command to do the next thing. And we'll go and send that. It will do exactly the same thing, unless I've made a mistake. So this just allows you to specify things in a little shorter format. And then do the animation. Now, this here looks a little bit clumsy, because I have to define it, animate, define it, animate. And in this case, the time that I'm doing to make the change, I'm saying do it over a second, and then I'm saying animate for a second. They're the same. So if I'm doing that sort of animation, I can switch and use what's called immediate mode. So I'm going to define this, and I want you to do the animation right away. So once again, we'll execute it. It'll run just the same as the other versions we were running before. And I can have out here, I can have as many channels listed as I want to. Now there's also an alternate, which I may not get to in here. There's what's called sequential mode. If I'm going to list like all 7, it's a little annoying to have to say channel 0, this value, channel 1, this value, channel 2, this value, channel 3, this value, and so on. So I can specify them all just using numbers. That uses the S command, sequential, rather than the direct command. So let's say I want to do something more than just specify specific LEDs. I want to change the LED that I run. So the language also specifies, allows for looping. So I have a for loop here, and the for loop looks pretty much the way you would expect it. So I'm going to start with channel 0, work through channel 7, and I'm going to do the dim immediate over a second of whatever channel I list to 1 and then back to 0. So this is the same animation we've been doing, except I'm going to change the channel each time. So now, let's see if we can watch this. Notice as you watch in the video, each second it goes down to the next video, to the next LED. We'll get all to the bottom, and then, no surprise, it goes back and up to the top. Now this works the way for loops generally work. I could specify here, which is the step, so this would be every other LED. I could specify negative numbers here if I'm going to start at a high number and go to a low number. Now the most obvious question here is, can I have more than one for loop? And sure, here's an example where I have a nested for. So here I'm going to have one for loop that sets the cycle time, how long it's going to run, or how long it's going to take to do an animation. And we're going to see it starts at 100. Well, I'm actually going to change this. Let's start at 70. So run a little quicker. So start at 70, go down to 10, subtract 30 each time we go through. And then we have the same animation we had before, going through each channel, except now we say the cycle is based on this variable from the for loop, rather than coming from a fixed value. So let's go and run that. What do we see? Well, we see we'll work our way down. This is the first time through the for loop, so the cycle is 70. Now we'll get to the bottom. Notice they go quite a bit faster. So the second time through, the cycle is 40, and then the final time through, you notice they went very fast. So we have this ability to do both for loops and use them within that. And yeah, you can use these variables within for loops if you wanted to. I don't have that sort of example here. So sometimes when you're writing for loops, obviously it might be nice to know what's going on. So let's move to another example. The language actually supports two print commands. So print means, P means print, and PL means print with a line afterwards, or a new line afterwards. So this will go back, and this is kind of a quick, notice it's going through the channels, and if we look over here at our output, we'll see that it's just cycling through. Cycling through each of the channels, doing what we'd expect. So over half a second. It's doing that, and we can look over here and we can see that the output is just what we'd expect. So that I don't use a ton, but it can be useful at specific times. There are also times when you don't want everything to be predefined. You'd like to add in a little randomness. So the language has some pretty rudimentary support for generating random numbers. So if you can see our first statement here, we're going to generate a random number. 0:8 actually means 0 through 7. That's the current syntax. I don't know, it might change. It's a little confusing. We assign that to channel here, and then we're going to turn it on quickly and then kind of turn it off a little slowly. So let's watch what happens there. So we just see now it's randomly choosing an LED and performing the animation on random choices. This is really nice when you're doing animations. A lot of times you'd want things not to be so fixed, but to have some degree of randomness. This is currently using the standard Arduino random functions. I think those are probably good enough for this sort of animation, and they're pretty quick. So that's what they use. Now, if you've noticed, earlier I talked about the D command and the A command, and then all the examples I've shown since then use DI. And the question is, why would I use D commands? So the thing about DI commands is that the amount of time you want the animation to take is also the amount of time you do animating. So it means you can only really have one kind of animation running at a specific time. So if we want to have overlapping animations, we need to do something different. So we're going to modify this past one, this previous one, just a tiny little bit. I don't know why I have a semicolon there. We're tiny little bit. So we'll get the channel randomly. We will drive that channel to full on, just in one step. So it'll go bright pretty much instantly. And then we're going to say over 40 cycles, we're going to drive that channel back to 0. So we're going to kind of slowly dim down. But then note that we're only going to animate for 20. So what does that mean? Well, we'll come through, we'll turn a channel on fully, and then we'll define what the channel is supposed to do for the next 40 cycles. But we'll only animate for 20, which means after we animate for 20, we'll come back around to the top and we'll choose another channel, drive it to 1, and tell it to dim down over 40. So essentially what that means is one channel will dim down halfway and then we'll start up another channel. So the first channel will finish dimming while the second channel is starting dimming. So we go ahead and execute that. What you notice there is we essentially have more than one dim going on. Notice you can generally you will see two dims. There's one kind of finishing and one going bright. So kind of a different sort of look. And a lot of the animations I've done in the past require this sort of thing. So that's really why you have the difference between normal mode and intermediate mode. And kind of going to my last example here. One of the requirements I had for the language was that I'd be able to build what's called a Larson scanner, where you just scan one direction and back. So that's one of the reasons I have normal mode and intermediate mode. So let's look at our code here. This is really the first half of the scanner. So for A equals, I should really, let's actually call this channel. We'll make it look nicer. We're going to do what I did. Turn that channel to 1, and then we're going to, over a period of 50, or half a second, we'll dim that down to 0. But then we'll only animate for 12. So what you can see is roughly we'll have 4 things lit at once. So this one will be lit all the way to 1, and then the one we did previously will be about 3/4, the one we did previously to that about half, and the one we did previously to that about 25%. So if we send that, what we'll see is we start to get the chasing that we want. So we have the front LED, or the current LED, is running at full on, and then the ones that are following it are less. It really doesn't show up that well in the camera. They all kind of look the same. And then if we have that, just going to put in the second half here. Okay, let's call that. So let's call that channel again. So this time we're doing the same thing. So the first part did channels 0 through 6. So it's going to LEDs, the first LED through the 7th LED. And then the other one will do the 8th LED back to the first LED. So you notice we have our little 4 here going the opposite direction. And this inner part is the same code. So now we hit send, and what do we get? We get back and forth animation. And this is enough. I have a Halloween project I'm working on, and this is enough support to do that project. There are obviously a lot more things I could do in the language. And they may show up, they may not. Basically my approach here is I'm going to just add stuff as I need it. The real goal here is to write my animations, in the browser using this nice simple format that just takes a second to send across and execute, rather than having to rebuild, write in C++ and rebuild and send stuff across. The other obvious question, this is just running single channel. The obvious question is, would you do this for RGB LEDs? And I think the answer is yes. I'll probably have to revise the language a little bit. Luckily the ESP has quite a bit of memory, so I think being able to keep like nice addressable RGB animations in, I think that's pretty simple. So, but I will have to figure out how to fit RGB into the language. And that will probably also require putting in expressions to do calculations and things like that. They aren't in there yet, but it'd be pretty straightforward to add. So that's all I wanted to show. And this is the current little project. If you want more, you can find information on my EagleDecorations website. Or you can find me either on Tindy or on Etsy, depending on what you're looking for. Boards like this show up on Tindy because they're more electronic. Some more ornament sort of stuff show up on Etsy. So, thank you for your time.